Hi everyone, in this video we're going to learn about the unit circle. The unit circle is probably one of the most important things that you learn in pre-calc. It's the basis of a lot of the trig that we are going to continue with in this course. So it's really important that you really understand the unit circle. So the first thing you have to know is unit circle. It's called unit because it has the unit radius or a radius of 1. So we're just going to jot that down really quick so that you know the unit circle has a radius of 1. So it's a circle with radius 1. And this particular circle in pre-calc will always be centered at the origin. So we're going to put this circle on the coordinate plane with the origin as its center. So if you look at my picture here, this is a blank unit circle and its center is at the origin. Okay. So now in this video, what we're going to do is we're going to build the unit circle. We're going to build it based on what we know about reference triangles and our special right triangles. To start though, when I look here at my coordinate plane, so my coordinate plane is here, and my radius is 1, I can figure out these points. These are terminal points. We already learned terminal points. There are points on the terminal side of an angle. So these terminal points that we're going to pick out from the unit circle are all terminal points that lie on the circle itself. So here, here, I'm pointing out to these first because they are going to be points that we should know without doing any angle work, right? So if this is the center and the radius of the circle is 1 and I'm just going directly horizontal, I know that this point is the point 1, 0. Okay, for this one, again, I'm starting at my origin. I know this radius is 1, so this has to be the point 0, 1. From here to here, this has to be the point -1, 0. And then from here to here, this has to be the point 0, -1. Okay, and these points are going to correspond with these degree and radian values. So this is 0 degrees, right? So we're going to measure these all in standard position. I'm going to use the positive x-axis as my initial side, and I'm going to go right now in the positive direction. So this is 0 degrees or 0 radians, and that has a terminal point of 1, 0 on the unit circle. Up here, we know that this is 90 degrees, or pi over 2, and that has a terminal point of 0, 1. Over here, the -1, 0 point, this is equivalent to 180 degrees, or pi. And then down here, this is equivalent to 270 degrees, or 3 pi over 2. And then if we went full circle, we know that that's 360 degrees, or 2 pi, and that has a terminal point of 1, 0, the same as 0 degrees and 0 radians. Okay, so now what we're going to do in the rest of the video is we're going to build up what these are. Okay, so what are these angles? What are these terminal points? And then we're going to get to, okay, so like, what do we use this for? So in my next slide, I'm just going to focus in on quadrant 1. If we really understand quadrant 1, it's fairly simple to get the rest of the circle using reflection, and I'm going to show you that in quadrant 2. Okay, so here is my quadrant 1 zoomed in. Okay, we already know that this is 1, 0, and that this is 0 degrees and 0 radians, and we know this is 0, 1, and that this is 90 degrees or pi over 2. Okay, so now we're going to fill in these. Now all of these are going to be multiples of our special right triangle angles, so they're going to be the 30s, 45s, and 60s. This first one is going to be 30. This one's going to be 45, and this is going to be 60. Okay, the equivalent in radians is going to be pi over 6, pi over 4, and pi over 3. Okay, but now the trickier part is to figure out what these terminal points are for these specific angles. So remember when we were doing reference triangles that we have an angle here. The angle that it makes with the x-axis is the reference angle. So for this first one, that's 30 degrees, right? Because I said this angle is 30 degrees here. Okay. So now if I were to do the same thing I was doing before, I'm going to drop down this side of the right triangle that makes the right angle. And I see here that this is actually a 30, 60, 90 triangle. Okay. So now in this 30, 60, 90 triangle, I should know the sides, right? The sides opposite 30 is always x, opposite 60 is x root 3, and opposite the right angle or the hypotenuse is 2x. But I also know, because this is the unit circle, that the radius of the circle, so from the center to the terminal point, that's a radii, or one of the radii, that's 1. So this 2x has to equal 1. So if 2x equals 1, I should be able to pick out what the other sides are. If 2x equals 1, then x equals 1/2. So that means that this side here is 1/2, and then this side is 1/2 times root 3, which is the same as root 3 over 2. So now let's think about what this means for the terminal side, the terminal point. So from here to here, what I just marked in yellow is how far I move from the origin to the x coordinate of my point, right? Look at it. It goes as far as my x coordinate of my point. My point is here. So that means that this side is equivalent to the x coordinate of the terminal point. So this, in fact, is root 3 over 2. Okay, and what about my other side? So my other side here, from here to here, is how far up I have to go to get to the point, or the y coordinate of my terminal point, so that's 1/2. So now I just figured out that the 30-degree angle on the unit circle has a terminal point of root 3 over 2, 1/2. Root 3 over 2, 1/2. And I'm going to talk to you about how we can use that in just a minute. I just want to continue building this section of the unit circle. So I am going to now do the 45-degree angle. So it would be that I'm dropping down here, but I'm going to do it on the side so you could see it better. So here is what I have. This is 45 degrees. This is the right angle. So that means, and the point's up here, right? This is the point that I'm trying to fill in. That means this is 45 degrees. Okay, in my 45, 45, 90 triangle, I know that opposite the 45s are x's, and opposite the right angle is x root 2. But remember again that this is the unit circle. And in the unit circle, I know that the radius, which would be from here to the terminal point, so from here, because that was the center, to the terminal point, has to be 1, because by definition, the unit circle has a radius of 1. So actually what that means is every time I go to construct one of these right triangles, the hypotenuse is going to be 1, because that radius is always going to line up as the hypotenuse of the triangles. So now that I know that, I am able to figure out what x is. So x root 2 equals 1. So when I go to solve for x, I'm going to get that x equals 1 over root 2, but I know I need to rationalize. So that's going to be x equals root 2 over 2. So this x is root 2 over 2, and this x is root 2 over 2. And using the same reasoning that I did before, from here to here is how you would travel horizontally to the point, or the x-coordinate. And then from here to here would be the y-coordinate, because that's how I travel vertically to the point. So the point here would be root 2 over 2, comma, root 2 over 2. Okay, and our last triangle here I'm going to draw on the side again. So this triangle is the one that has a reference of 60 degrees. So I know that this angle here is going to be 30 degrees. I know this is the origin and this is the terminal point that I'm trying to figure out. I also know that opposite the 30-degree angle is going to be x, opposite the 60 degree is going to be x root 3, and then the hypotenuse is going to be 2x. Once again, I know that the hypotenuse equals 1, so 2x equals 1, meaning x is 1/2. So that means that this side is 1/2, and this side is root 3 over 2, because 1/2 times root 3 is going to be root 3 over 2. So now I pretty much have the whole first quadrant figured out. Now if I look at, I'm going to just keep this this one here open. Okay, just erase the stuff that got me there. Okay, so I know that this terminal point is 1/2 comma root 3 over 2. So what does that tell us? What does that tell us? It tells us something very specific, actually. So let me fill this in again too. This was 1, this was root 3 over 2, and this was 1/2. Let's say I wanted the cosine of 60 degrees. The cosine of 60 degrees. The cosine of 60 degrees is going to be the adjacent. So here's the adjacent over the hypotenuse. So I'll have 1/2 over 1, which is just 1/2. So the cosine of 60 degrees is 1/2. It's always 1/2, right? We already know that. But where do I see that in my terminal point? Cool, right? So the x-coordinate here is actually the cosine of the angle. Okay, what about sine? I don't know, let's see. Sine of 60 degrees is going to be the opposite over the hypotenuse, so root 3 over 2 divided by 1, that's just root 3 over 2. And that ends up being the y-coordinate. Pretty cool. And that will actually happen every single time, because if you think about it, for all of these triangles, if the hypotenuse is 1, when you do cosine and when you do sine, the hypotenuse is always the denominator. So what ends up happening is that opposite side, which is equivalent to the y-coordinate, is going to be just what the sine equals, right? Because that over 1. So that ends up being all the y-coordinates, and the x-coordinates is always just going to be the adjacent side, because it'd be the adjacent over 1, which ends up being just the adjacent, which is the x-coordinate each time. So this is pretty cool, right? If I know the terminal points on the unit circle, I know all the cosines and all the sines of every angle on the unit circle. So let's write that down. X is the cosine and y is the sine. That's really, really important information. Now, something else actually comes up out of this, right? So if I know the cosine and I know the sine of each angle, I know its reciprocals, right? Because if I wanted, let's say, the secant of 60 degrees, I'll look at the x-coordinate at 60 degrees is 1/2, and I'm just going to find the reciprocal. The reciprocal of 1/2 is 2. So I don't have to go making special right triangles every single time or make a reference triangle every single time. If I know these terminal points, I can do it just by knowing the terminal points, just by picking out either the x or the y coordinate. Same thing for cosecant, right? If I want a cosecant of 60 degrees, I would just take the reciprocal of sine of 60 degrees, which is the y coordinate at 60 degrees. Now let's say I want a tangent though. If I want a tangent, I have to know something very specific about tangent. So let me make sure that you know this fact. I think that some of you might already know it, but just in case. Okay. So let's think about how tangent is related to sine and cosine. So we already know that tangent is opposite over adjacent, right? We know that cosine is adjacent over hypotenuse, and we know that sine is opposite over hypotenuse. Okay? So it seems like there's a way to do something with sine and cosine in order to get tangent, right? Because sine has the opposite, cosine has the adjacent. The only thing tangent doesn't have is the hypotenuse. So what happens if I divide sine by cosine? Okay, let's see. Sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. So now I am dividing a fraction by a fraction, and we know that that's equivalent to multiplying by the reciprocal. So I'm going to have opposite over hypotenuse multiplied by the hypotenuse over the adjacent. And now I see the hypotenuse over that hypotenuse is just 1. So I end up with the opposite over the adjacent, and opposite over adjacent is equal to tangent. So I just proved that tangent is equivalent to sine over cosine. Tangent is sine over cosine. So when I want to find tangent of a specific angle, I can still use the unit circle. What I'm going to do is I'm going to take the sine or the y coordinate of that specific angle's terminal point, and I'm going to divide it by the x value or the cosine of that specific angle's terminal point. So let me give you an example. So let's say that I was trying to find the tangent of 45 degrees. Well, I know x is the cosine, y is the sine, making tangent equivalent to y divided by x, right? Sine over cosine. Okay, so now if I look at 45 degrees, which is right here, and I look at the terminal point is here, I'm going to take the y and divide it by the x, so it's going to be root 2 over 2 divided by root 2 over 2, which is really just 1, right? Anything divided by itself is 1. The tangent of 45 degrees equals 1. And I just figured that out using my unit circle. I did not make any special right triangles. I am just using the terminal points of my unit circle. Okay, so this is how we're going to use the unit circle. Now I'm just going to build the rest of the unit circle. I'm not going to do each triangle each time. I'm going to look at the first quadrant and see if I could develop the rest from the first quadrant. Okay, so I'm going to fill in what I already know. So this was 0, 0, and this was the point 1, 0. This was 30 degrees or pi over 6, and this was the point root 3 over 2, comma 1/2. This was the angle 45 degrees or pi over 4, and the terminal point was root 2 over 2, root 2 over 2. And then here we have 60 degrees and pi over 3, and the terminal point was 1/2, comma root 3 over 2. And then here is the 90-degree angle or or pi over 2, and this point is the point 0, 1. And then we already knew that this was negative 1, 0, and this is 180 degrees or pi. And now what we can see here when we get to this quadrant is that because we're going to the left of the origin, all of the x values are going to be negative. But when we go to make the triangles, it has the same absolute value as the other side, it's just that the x values are going to be negative. Right? And I could figure this out using a reference triangle, using your reference angle, but it's always going to be that case that everything in quadrant 2 is going to have x values that are negative and y values that are positive. So when I go to build it, it's actually going to be almost the same points as we have here. It's just going to be that the x coordinates are negative. Right? So I do have to figure out what these angles are. So this angle here is going to have a reference of 60 degrees. So that means this is the angle 120, which is equivalent to 2 pi over 3. Okay? If I go to make this triangle, the terminal point is going to be negative 1/2, comma, root 3 over 2. Okay? Our next angle is going to have a reference of 45 degrees. So this is going to be the angle 135 degrees, or 3 pi over 4. And its terminal point is going to be negative root 2 over 2, comma, root 2 over 2. Okay, next angle is the one with the reference of 30. So this is going to be 150 degrees, or 5 pi over 6. And its terminal point is going to be negative root 3 over 2, comma, 1/2. Okay, so now we're going to just fill in the rest using these same facts. So using the fact that when you get into a different quadrant, you'll have the same triangle, so the terminal points will have the same absolute value, but based on its position on the coordinate plane, some things might be negative, some things might be positive. So let's continue building. Okay, so now I have the rest of the unit circle, sorry. So let me just put in what we already know. So this is 1, 0, 0, 0. 30 pi over 6. 45 pi over 4. 60 pi over 3. This is 90, which is pi over 2. 120, which is 2 pi over 3, 135, which is 3 pi over 4, 150, which is 5 pi over 6, and 180, which is pi over 2. Okay, and all the terminal points we already know, but I'll still fill them out. So this is root 3 over 2, comma, 1/2. This is root 2 over 2, comma, root 2 over 2. This is 1/2 root 3 over 2. This is 0, 1. Here we have negative 1/2 root 3 over 2. This is negative root 2 over 2, comma, root 2 over 2. This is negative root 3 over 2, comma, 1/2. And this here is negative 1, 0. Okay, so now the rest of the unit circle is going to have the same reference angles. The only difference here is that the terminal points may have different signs. So this first one here has a reference of 30 degrees. So this is the angle 210, or 7 pi over 6. And this terminal point, now that I had to go to the left of the origin and down, both the x and the y values are going to be negative. So this is going to be negative root 3 over 2, comma, negative 1/2. Okay, now my green angle here is going to have a reference of 45 degrees. So this is going to be 225 degrees, or 5 pi over 4. The terminal point is going to be negative root 2 over 2, comma, negative root 2 over 2. Okay, my blue angle here is going to have a reference of 60 degrees, so this is the angle 240, or 4 pi over 3. And its terminal point is going to be negative 1/2, comma, negative root 3 over 2. And then here, this is 270 degrees, or 3 pi over 2. And this is the point 0, negative 1. Okay, now this angle has a reference of 60 degrees, so it's 300. And it is equivalent to 5 pi over 3. The terminal point now, because we're going to the right of the origin and down, is going to be positive 1/2, comma, negative root 3 over 2. This angle here has a reference of 45 degrees, so this is going to be the angle 315 degrees, or 7 pi over 4. Okay, and the terminal point here is going to be root 2 over 2, comma, negative root 2 over 2. And here we have our 30-degree reference, so it's going to be 330 degrees, or 11 pi over 6. And our terminal point here is going to be root 3 over 2, comma, negative 1/2. And last but not least, if you do one complete rotation, that's 360 degrees, or 2 pi. And that's still the point 1, 0. So another thing we really need our unit circle for is for those quadrant angles. So if I wanted, let's say, the sine of pi over 2, sine is equivalent to y. So I'm going to look at my y coordinate at pi over 2, that's 1. So the sine of pi over 2 is 1. Another thing I could ask you for, let's say, is the tangent of 270 degrees. So tangent, we know, is equivalent to sine over cosine, which means it's y over x. So that means this is going to be negative 1 over 0, but when you divide by 0, we get something that's undefined. So actually, tangent of 270 degrees, we would say, is undefined. So again, another reason why we need the unit circle. Okay, also in the unit circle, you could see what's positive and what's negative, like which trig functions are positive for those angles or in that quadrant and which one's negative. So in quadrant 1, everything is positive, so all are positive. Okay, in quadrant 2, the x values are negative, so that means cosine is negative. If cosine's negative and sine's positive, when you divide a negative by a positive, you get a negative. So in quadrant 2, tangent is also negative. So the only thing positive in quadrant 2 is sine. Everything else is negative. And when I say sine is positive, that also means that cosecant is positive. It's reciprocal, takes the same sign. In quadrant 3, we have cosine negative, we have sine negative. The only thing that's positive is tangent, right? Because if you divide a negative by a negative, which you do for tangent, right? We're going to divide the y's by the x's. You will get a positive result. And then in the last quadrant, the x's are positive, so cosine is positive. But tangent is going to be negative and sine is going to be negative because the y's are negative. Okay, so a lot of people use the saying, all students take calculus, to remember this, especially since you're in pre-calc. So all means that they're all positive, students means that sine is positive, take means that tangent's positive, and calculus means that cosine is positive. If it's not that, so like in quadrant 2, it only says sine is positive, that just implies that all the other ones are negative. But remember what I said, that reciprocals take the same signs. So like when sine's positive in quadrant 2, so is cosecant. When tangent's positive in quadrant 3, so is cotangent. When cosine is positive in quadrant 4, so is secant. So that's how it works. So like I said, the specific questions I would ask you are things like this, that I did a few of already. I could also ask you, for instance, let's say cosine of 7 pi over 4. And you would say, okay, well, that's the x-coordinate at 7 pi over 4, so that means this equals root 2 over 2. So questions like that. I could also ask you, like, is this terminal point on the unit circle? Is this terminal point on the unit circle? One, you could look at that, right? You see the ones on the unit circle. But also what you can do is, you know that on the unit circle, the radius is 1. So in order for a point to be on the unit circle, when you do the Pythagorean theorem with it, it would have to equal 1. Other questions that I could ask you are ones that are coterminal with these. So that's why you really need to know coterminal angles. Like something that could be asked is, okay, what's the sine of 390 degrees? So 390 degrees is not given to you on the unit circle, but you could figure it out by using a coterminal. Remember, we already established that coterminal angles land in the same spot, so they have the same trig values. So sine of 390 degrees would be the same as sine of 30 degrees, because 30 degrees is coterminal. And then you would just look at 30 degrees, y value, okay, that's 1/2. So that's how you could use it for coterminals. And there's other things you could use for the unit circle that we will go over in class, but these are the main things that you need to know. So you should have a unit circle handy. You should have it written out. In the beginning, you're going to need to reference it a lot until you memorize it. But most people memorize the unit circle, and that's how you know all these, like sine of 210 degrees and things like that, like, you know, instantly. And it's only going to give us exact values, and that's what we want. Okay, so this is the unit circle. Make sure that you have it. Again, I would write this down. I would draw a picture, and I would reference it as much as possible.